There's a couple of more problems in section 2.2 that I wanted to look at. Let's consider this problem here. And again, the method is separation by variables. So we want to multiply both sides by dt, divide both sides by x squared plus 1. So we end up with 1 over x squared plus 1 dx is equal to 4 dt. We now integrate both sides respectively with dx on the left side, integrating with respect to x on the left, integrating with respect to t, on the right. Now, think in calculus, we beat you up long enough to know that when you see the integral of 1 over 1 plus x squared dx, you know that's going to automatically be tan inverse of x, right? Were you beat up enough with that, those trig forms? You might need some more beating up, right? Well, you join my fraternity and they'll beat you up a whole lot. But anyway, well, they didn't beat me up, and so praise the Lord for that. So tan inverse of x. It looks like here t is the independent variable, so we associate the constant with the independent variable. This is equal to 4t plus c. So for the initial condition, it says that when t is equal to power of 4, x is equal to 1. So you notice here that this is the same, say, if and only if we take the tangent of both sides, this is x is equal to the tangent of 4t plus c. Well, since we're given the initial condition, then we need to solve for that c. And once we have that value for c, then you have the answer based on the initial condition. So if I come here to this statement, and if I write tan inverse of x, let's say is equal to some number that we don't know, let's say y. So this is if and only if here y is equal to, well, tangent of y is equal to x. All right, now let's see. Let's put this in blue. So what I'm given is that I know that x is equal to 1 when t is equal to power over 4. So over here, I have this tan inverse of here, x is 1. That's equal to y. So that's if and only if tan y is equal to 1. Well, just a very simple value for y in the first quadrant would be y would have to be power over 4. Right? The tangent of power over 4, 45 degrees, would give us the tangent of power over 4 is equal to 1. So this implies that y is equal to power over 4. So, but y is said to be this tan inverse of x. That's this statement right here. So I'm going to come back and replace the tan inverse of here, x being 1, to equal to power 4. That's equal to 4 times t. T is power 4 plus c. So what I have, this statement, this tan inverse of 1 is equal to 4 times t. T is said to be pi over 4 plus c. But tan inverse of 1 is equal to power over 4. So this is power over 4 is equal to pi plus c. So subtract pi on both sides. C is equal to pi over 4 minus pi. That is negative 3 pi over 4. That's for C. So the answer is this statement right here, just with the value of C. Right? So here we have x is equal to the tangent of 4t minus 3 pi over 4. Is that okay? There's a couple of things that you have to remember. One, that remember those trig integrals, that the integral of 1 over x squared plus 1 dx gives you tan inverse of x. And then to also remember, when dealing with those inverse trigonometric forms, or the arctan, the arcsine, arc cosines, that the equivalent relation, that tan inverse of x is equal to y, if and only if, just take the tangent of both sides. Tan y is equal to x. I think once you know that, remember that, you should be good. Okay. Let's look at another one that still gives us some more insight. Let's cross multiply, and when you do, you get x squared minus 1 dy is equal to y squared minus 1 dx. But the variables are not separable in terms of the x's are not with the dx's and the y's are not with the dy's the way we want them. So you could have done that really the first stroke, but we're going to divide both sides by the x squared minus 1 and then divide both sides by the y squared minus 1. And so what we have is 1 over y squared minus 1 dy is equal to 1 over x squared minus 1 dx. So now they're separable. So the left side is the integral of 1 over y minus 1 times y plus 1 dy is equal to the integral of 1 all over x minus 1 times x plus 1 dx. Do not need the parentheses. Not now. So what is our method for solving this? Partial fractions decomposition, indeed. So for that left side, we have 1 over y minus 1 times y plus 1. We set that to equal to some constant a over y minus 1 plus some other generic constant b over y plus 1. It's that very similar setup on that right side with x. So that's 1 over x minus 1 times x plus 1 is equal to a over x minus 1 plus b over x plus 1. I'll solve the blue, and then since this is very similar, the same values will be for the a and b over here for the x's. It's blue. So if you multiply both sides by the LCD, this implies that we have 1 is equal to a times y plus 1 plus b times y minus 1. If you let y equal to 1, well, that'll get rid of the b. I can solve for a. So I get 1 is equal to 2a. So that implies that a is equal to 1/2. And then secondly, let y equal to -1 to cancel out the a to solve for b. So if y is -1, so I get 1 is equal to, this is 0 plus b times -2, -1 minus 1. So I get here 1 is equal to -2b. That is, b is equal to -1/2. So the same thing happens over in black. Same setup, right? Everything there is the same. So over here, a is 1/2 and b is -1/2. So we go back to that integral. So the left side is the integral, and if it's okay, since they're both, a form of 1/2, one is negative, the other is positive, I'm going to put that 1/2 out in the front, and I'll just make sure that I note that with the signs. This is 1 over y minus 1, right? And b, since it was, this is b. Sorry. So this is minus 1. It's minus 1/2, but put the 1/2 out in front. And this is y plus 1 here. This is yes. And then it's a very similar setup also for what's happening over here. So this is equal to 1/2 times the integral brackets 1 over x minus 1 minus 1 over x plus 1. That's dx. So we integrate, well, these are natural logs. So this is 1/2 times the natural log of the absolute value of y minus 1 minus 1/2 times the natural log of y plus 1 is equal to 1/2 times the natural log of absolute value of x minus 1 minus 1/2 times the natural log of x plus 1. And then this is plus some constant. So plus the natural log of c. Well, heck, I just figured since we're taking the natural log of everything, take the natural log of that c too. It won't hurt it. C is a constant. Natural log of c is still a constant, so we're fine. All right. Multiply everything through by 2, and then since we know the property of logs and natural logs, we can combine those terms. The difference becomes the ratio. So what we have in simplified form is the natural log of the absolute value, yes, y minus 1 all over y plus 1 is equal to, multiplied by the 1/2, is equal to the natural log of x minus 1 all over x plus 1, and then here plus 2 times the natural log of c, and that's fine. We're still going to just claim that as just the natural log of c. 2 times the natural log of c is natural log of c to the second, but that's still a constant, so we're okay. Exponentiate both sides, and when you do that, do you see that what you have, I'll put that 2 there just so that you don't have a fit. I'll put that 2 in there. So this implies that y minus 1 all over y plus 1 is equal to some constant times x minus 1 all over x plus 1. I guess I better call that constant something else. Let's call it k. K is equal to e to the natural log of c squared. Exponentiated everything. Bless you. Bless you. Did they give us any initial condition? Yes. X equal to 2, y is equal to 2, right? So if that be the case, x is 2, y is 2. So here we get 2 minus 1, we get 1 all over 3 is equal to 1/3 times k. So that implies that the constant is equal to 1. And so the answer is y minus 1 all over y plus 1 is equal to x minus 1 all over x plus 1. Can we simplify this answer any further? If you think a little bit, you'll get it. No. That's the answer. Y is equal to x. For whatever value you pick for x, you end up with that same value for y. They have the same form, right? The left side to the right side. Same form. Matches up identically. We kind of get a hint here, because here x equal to 2, y equal to 2. That's not always the case, so we can't just go on point. But if you let, say for example, x equal to, let's say 5, just pick any number. So I get y minus 1 over y plus 1 is equal to 5 minus 1, 4, all over 5 plus 1, 6. That implies cross multiply. So I get 6y minus 6 is equal to 4y plus 4. Subtract 2y on both sides, so I can get, well, that is 4y, I get 2y, and then add 6 on both sides, I get 10, you get y is equal to 5. Now you can sit there and do that for all real numbers, and so let x equal to 30, you end up with y equal to 30. Let x equal to 15, you end up with y equal to 15. Let x equal to 1/3, you end up with y equal to 1/3. Just keep doing that until you get all the numbers. Or you really see here that that this equation is somewhat reflexive. That is that y is equal to x. Right? Now, again, if you told me this, if you gave me that on the test, then I'm fine with that because that is true. That is the answer. Okay. Any questions? Yes, sir. Hmm? That was the one? Okay. Oh, this one here. Oh, not the previous one. Okay. Because I was going to give you this one to do in class. But this is one you want me to do, right? So I should have given you the other problem to do in class, and I could have worked this one. So, man, more work on me. Doggone it. All right. So let me work this one, and then we'll go. I'm going to skip 2-3 and go to 2-4, and then we'll come back to 2-3 on next week. Let's see. So we're going to multiply both sides by dx. So you get x squared dy is equal to parentheses. And we need to go ahead and factor out a y is common. I see that. Do you see that? Y is common in those two. So we just factor out that y while we're there. 1 minus x dx. Separate the variables. So divide both sides by x squared and divide both sides by y. So we get 1 over y dy is equal to 1 minus x over x squared dx. Well, this is 1 over y. We're going to integrate that. Dy is equal to the integral. Now, 1 over, you can always break down if you have a plus or minus b over c. That's the same thing as a over c plus or minus b over c. So we can break this down as 1 over x squared, then minus 1 over x dx. So we integrate, so it gives us the natural log of absolute value of y is equal to, you integrate x to the negative 2, that becomes negative times x to the negative 1. So this is negative 1 over x minus the natural log of absolute value of x, let's say plus some constant there. And so how come I don't make the c the natural log? Well, everything here is not natural log because of that negative 1 over x. If that was natural log of that guy, then I'll make that c natural log as well. I integrated it. Yep. See, isn't that the same thing as x to the negative 2? So you integrate that. That's negative x to the negative 1 plus some constant, or negative 1 over x, right? I'm going to get the like terms together. So I'm going to add natural log of x to both sides. And when I do that, I'm going to go ahead and combine. This is the natural log of x y is equal to negative 1 over x plus c. Exponentiate both sides, so I get xy is equal to e to the negative 1 over x plus c up top. Excuse me. They give us some initial conditions, I believe. When x is negative 1, y is also negative 1. it's your choice of where you plug that in, whether here, or there. I'm going to plug it in right here. This implies that I have the natural log of 1. If x is negative 1, right? When y is negative 1. So if I plug in that, I get negative 1 times negative 1. I get just 1. Natural log of 1 is equal to negative 1 divided by negative 1. That's 1 plus c. What's the natural log of 1? 0. So this implies that c is equal to negative 1. So I get x times y is equal to e to the negative 1 over x minus 1, because I get c is equal to negative 1. Oh, drawing's not so good. And to get your answer to look like that, just divide both sides by the x. So we get y is equal to e to the negative 1 over x minus 1, and that's all over x. Right? You factor out a negative from there, and you get that expression. Everybody happy so far? Okay. Any other questions? All right, stop here and pull up the next slide for section 2.4, and we'll look at some of those problems.